In Lesson 9.6, you will graph linear equations using the slope and y-intercept. Slope-intercept form of an equation is y equals mx plus b, where m represents the slope, or rise over run, and b represents the y-intercept, or where it crosses the y-axis. In example 1, it says state the slope and the y-intercept of the graph of each equation. So you're going to just look at the equation y equals 2/3 x minus 4, and you are going to identify the slope. Slope is the number in front of x when it's in this form, so the slope is going to be 2/3. The y-intercept is right here, and this minus 4, remember, is like adding a negative 4, so since it's minus 4, the y-intercept is going to be negative 4. In example 2, you have to do a little bit of work before you can identify the slope and the y-intercept, because this right now is not in slope-intercept form. In order for it to be in slope-intercept form, it needs to be solved for y. In other words, y needs to be by itself. If I wanted to get y by itself, I need to get rid of this x. To get rid of 1x, I would subtract x from both sides. So on the left side, I would have y. And then on the right side, these are not like terms, so we're going to leave them as two separate things. But rather than writing 6 minus x, I'm going to put a negative x plus 6 because I want it to be in this form up here where I have the x term first followed by the constant term. And since this is minus x, that's like a negative x, so that's why I put a negative x here. And since there's no sign in front of this 6, that's a positive 6, so plus 6. Now the slope is the number in front of x, or the coefficient of x. Since there isn't a number there, it's a 1. So that means the slope is negative 1, and the y-intercept is this piece right here. And since it's a positive, it's going to be just 6, since it says plus 6. You may want to pause the video and try the next 3 examples on your own. This first one is already in slope-intercept form. Remember, y equals mx plus b, where m is the slope and b is the y-intercept, or where it crosses the y-axis. So in this particular equation, the slope is going to be the coefficient of x, or the number in front of x, so negative 5. And then the y-intercept is this piece right here. Since it's plus 3, it's going to be a positive 3. In the next example, this one is also in slope-intercept form, so the slope is going to be the coefficient of x, or the number in front of x, which is 1/4. And then the y-intercept is this other piece here, and since it's minus 6, that's going to be a negative 6, because remember, subtracting 6 is the same as adding a negative 6. And then the last example, this is one that's going to require more work again because it's not in slope-intercept form. Y is not by itself yet. In order to get it by itself, we need to get rid of the minus x. We're going to get rid of that minus 1x by adding x to both sides. So I end up with y equals, now to have it in slope-intercept form, I'm going to put the x term first. It's a positive x, so just x, and that's a positive 5, so it's going to be plus 5, which means the slope is going to be the number in front of x, or the coefficient of x, which is 1, and the y-intercept is this piece here. Since it's positive 5, it's going to be 5. The last thing we're going to do is graph using slope-intercept form. This is way quicker than having to make a table of values. If you want to graph y equals negative 3/2 x minus 1 using slope and y-intercept, you want to start by graphing the y-intercept. The y-intercept is negative 1, so you go on the graph to negative 1 and put a point. Step 2 is to use the slope to find a second point on the line. Remember, slope is rise over run. Or in this case, since it's a negative slope, instead of rising, we're going to fall or go down. Since the slope is negative 3/2, that means we're going to go down 3 since it's negative. 1, 2, 3. And then we're going to run to the right 2. If you have a negative slope, you want to only go in a negative direction once, because if you went in a negative direction on both of these numbers, a negative divided by a negative is actually positive, and this is a negative slope. So you only want to go in a negative direction once. I always choose to do it right away in the beginning by going either up or down, in this case down since it was negative, down 3 into the right 2. And then the last step is to take and connect those points with a line and put arrows on the ends to show that it keeps going in both directions. Now you may want to pause the video and try these next 3 on your own. For the first one, y equals x plus 3. The y-intercept is positive 3, so I'm going to go to positive 3 on the y-axis and put a point. And then the slope is the coefficient of x, which is 1. And since it's an integer, I'm going to go ahead and write it as a fraction by putting it over 1. That means I'm going to rise 1 and run 1. So rise 1, run 1. Now technically you only need 2 points, but to make a more accurate line, I like to make a few more so I can line it up well to make my straight line. So rise 1, run 1, rise 1, run 1, rise 1, run 1. You could also go down 1 and left 1, because again, if you go in a negative direction both times, that actually is a positive slope. Then you want to connect these with a line and put arrows on the ends to show it keeps going in both directions. It's always a good idea when you're done to look and see if it makes sense. Since this is a positive slope, it should be going upward, so that's a good sign, and it should be crossing through the y-axis at 3. Our next example, y equals 1/2 x minus 1. We're going to start by plotting the y-intercept, which is negative 1. So I'm going to go to negative 1 on the y-axis and put a point. And now the slope is 1/2, rise over run, rise 1, run 2. So rise 1, run 2, 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 and then go ahead and connect those with a straight line and put arrows on both ends to show that it keeps going. Basically, again, what this means is that any point, if I were to take the ordered pair of any point on this line, if I were to plug in the x value and the y value, it would work out and have the two sides being equal. All right, our last example, plot the y-intercept, which is a positive 2. And then the slope is negative 4/3. So instead of rising, this time we're going to fall 4 and run 3. So 1, 2, 3, 4 down and 3 to the right. Remember, for a negative slope, you only go in a negative direction one time. And I'm going to do that right from the beginning by going down 4 and to the right 3. Down 4 and to the right 3. And then go ahead and connect them with a straight line. Arrows on both ends to show that it keeps going in both directions. And once again, since it was a negative slope, your line should be going downhill, and it is. And it should be crossing the y-axis at positive 2.